Hello. So I've learned a lot of things in the intervening 2 minutes, and they are that you cannot see my cursor, which is fantastic. And maybe if I do this, I'll find out later. Oh God, because I've just been pointing at things. You can only see when I write, but I don't have time to go back and re-record. So sorry. And then I also learned I got the answer correct on the first one, which is good, which is nice. And that you cannot see my little MATLAB window where I'm calculating stuff. So uh, maybe I'll screenshot it and put it in the OneNote so that it shows up for you. All right. Hi, welcome back. I don't think I learned anything else interesting. So we have this problem, which I skipped over in class pretty quickly because I didn't really want to go through it because it takes a bit. But what we need to do is we need to find the tension in these three tables. So we have three unknowns. It's a 3D problem where all of the forces are concurrent, meaning they all act at this point, A. And so we can't really use our moment equations. Technically, we could take moments around like point C or D or whatever, but it won't give us anything that just doing the force equilibrium won't do. So we have three unknowns. And then we have three equations, so sum of fx equals 0, sum of fy equals 0, and sum of fz is equal to 0. Surprise! So we just got to set that up, right? So first we'll draw our free body diagram of point A. And we have force AB, force AC, force AD, and 120 kilograms times 9.81. Thanks, Mr. Newton. Okay, so to find these forces, which are vectors, well, I guess I'll leave them as, those are scalars, and then the actual, this thing is a vector telling us the direction. So to find, oh gosh, okay, force AB vector is going to be equal to force AB just as a scalar times a normal vector in the AB direction. Same thing for our others. Z normal vector in that direction, and force AD is going to be equal to FAD, normal vector in that direction. Great. So we just got to find these. So for NAB is going to be equal to, I'll do each of these in a different color. Why not? So to go from point A to point B, because that's the vector we want, right? We're going to go up 2.5 meters, and then we need to go half a meter. I guess I have to decide what my xy coordinates are going to be. So I'm going to make this be x, that be y, and that be z. Or wait, that's left-handed. I need to flip these. X, y, z. All right, so this time now it's right-handed. Okay, so we're going to say plus 2.5 in the z direction. So I'll write that in over here. 5 in the z. And then we're going to go in the x direction half a meter. So, and that's going right from here to here. So that's 0.5 in the x direction. And then in the y direction, we're going to go negative 1.5 meters. Oh, my hand's kind of cramping. Minus 1.5. Yeah, oh, yes, they're definitely equal. Okay. All right. So that is, these are all have dimensions in meters, because this is just the vector from A to B, so we need to divide it by 0.5 squared minus 1.5 squared plus 2.5 squared. So I'm going to go over to Monsieur MATLAB, which you'll just have to take my word for unless I can figure out how to screenshot it. So I'm going to say x is equal to 0. Oh wait. 0.5 minus 1.5 and 2.5. Okay. Let me screenshot it. I wonder if the screenshot, it worked, cool. Alright, let me paste that bad boy in here. So, yeah, let me just point out, just in case anyone's not that familiar with MATLAB, I've stuck this vector in here, so x, y, z, and I just divided it by the norm of the answer, which is this 0.5. It's the square root of x squared plus y squared plus z squared. So that's the norm of a vector. Right? So when you divide a vector by its norm, you get a unit vector. Alrighty. So that is AB right here, or NAB. This is NAB. I'm going to do the same now for our other two. I did not plan well space-wise. NAC. I'm going to do, apologies, NAD down here. And in between these two, to show they're different, I shall squiddle and squiddle. And worked it. Ooh, child, things are gonna get easier. Okay. So from A to D, we're going to go up 2.5 again. I promise different colors. Make it a bit thicker, just for emphasis. From A to D, up 2.5. And then in the y direction, we're going to do positive 2. And then in the x direction, we're going to go positive 0.5. Great. So, what did I just say? 2.5 in the z hat, meters. In the x one, that is 0.5. And then in the y one, positive 2. And we're going to want to divide that by its norm. That's technically bad notation, but whatever. So now I'm going to go over to MATLAB. Again, I'm going to do the same thing. This is the part where your calculator is doing the work. It's me. I'm your calculator. And your calculator is now screenshotting it and pasting it. Thank you. Hold the applause, please. I lost my pen. There it is. And I just remembered you still can't see my cursor because, of course you can't. All right. And that is an AAC. Little hat, because it's a unit vector. All right, 2 down, 1 to go. No one is hearing any of this, and that's probably for the best. Oh, that was, sorry. I did A, that was AD. Anno Dominus is what that means. That's Latin for. All right, now I need AC. That's a terrible C. AC. Okay. That one shall be in, I'm colorblind, so I don't know what color. 2.5 in the Z. And then 1.25 in the negative X. They're getting easier in the X direction, and then plus 2.5 in the Z direction. Alright, and and then divided by minus 1.25 squared plus 2.5 squared. Five, 0, 2.5. There he is. Hopefully you skipped all this, because if not, or maybe you're playing me on like quadruple speed and I sound so cool right now. Alright. Finally. Squiddle, 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 squiddle. Alright. So, we actually were doing a thing here. Hold up. I'm trying something. I'm doing something here. Okay, some of the forces vector is going to be equal to FAB, NAV, plus FAC, NAC, plus FAD, NAD. Right? And so that's going to be equal to, in the x direction, I'll write out this one and then I'll probably skip the other ones. So 0.169, or no I won't, what am I talking about? Alright, so that one, and then in the, I need to scroll down a little bit. Alright, so AB, I want AC, I want the minus 0.51 FAC, and then plus 0.15 FAD, move over a little bit more. And so all of that is in the I-hat direction. Now we need the J-hats. 0.5071. I'm going to forget that decimal if I'm not careful. AB plus 0.6172 FAC. Oh, I forgot to wait here. I'll add that later. What am I? Oh wait, there's nothing. There's no Y component for that one. Okay. Sorry, scattershot. This is the J-hat sum. I've switched from XYZ to IJK. Sorry. The thing I forgot to do, so this is an equilibrium problem. So we need to add in the weight, whatever that was. 120 times 9.81. So minus 120. Oh my god. 120 times 9.81, and that'll all be in the, no, I've switched in the k-hat direction. And since it's an equilibrium, it's equal to 0. Alright, finally, we have, look at some of our k-hats. So 0.8452 in the AB, 0.8575 in the AC, plus 0.7715 in the AD. And then finally minus 120 times 9.81 k-hat. And that's all equal to 0. Okay, so this is our system of equations. I'll write it as a matrix just so you can see that too, and also because I'm going to take it to MATLAB. I'm going to write it up here. Sorry. Alright, so our unknowns, and they be 3. We have FAB, FAC, and FAD. And then on the right side of the equation, we're going to move all the scalar stuff, so in that case it'll be this. So we're going to have only that 120 times 9.81. And then these will both be 0. And over on this side, we'll have 0.169, minus 0.51, 0.15, minus 0.5071. Oh, did I screw that up? Is that AD? No, I did. Yeah, this should be AD, not AC. Alright, so 0, 0.6172, and then finally 0.8452, 0.8575, 0.7715. Okay, so basically, as far as I'm concerned, the problem is done now. What I'm going to do is I'm going to stick these into my calculator, into MATLAB, and as I'm doing that, I'll talk a bit about what to do if something like this comes up on an exam. Oh, that is MATLAB. Okay, and then you are here. All right. So basically, I don't actually need you to solve all these if you're giving that on an exam. Like the equations, but I don't need to see your math is what I mean, mostly like your elimination. So if your calculator can do it, plug it into your calculator, say this is 3 equations, 3 unknowns, plug that bad boy in. If it can't, you'll get most of the points just for this part. Usually, we try to make it so that the matrices, the biggest ones you'll get, are like 2x2s, which you can definitely do by hand. Hopefully, if you can't do it 2x2 by hand, definitely practice that. Sorry. Yeah. Because or if they are 3x3, there'll be like some symmetry to it. Like maybe it'll be something like 1, 2, 3, 4, 0, 0, 5, 0, 0, something like that. Like that one you should be able to solve by hand, because it's basically this is going to be that guy, and then a 2x2. So you should be able to do 2x2s, basically. Okay. So, and then I've typed in the matrix, B is equal to 120 times 9.81, A divided by B. Alright, so I'm going to paste my MATLAB screenshots in here as well. Is that right? Let me double check. Sorry, I'm double checking with the solution document right now. Where am I? Sorry, my magnitude seems to be off by a bit. Oh, wait. Oh, sorry, it's doing an implicit expansion. I hope you skipped ahead if you got to this point. Again, not editing these. Sorry. Is the command for linear solver again in that one? I thought it was just backslash. Oh, it's because my B is a row vector. Sorry, God. If you know MATLAB, you know the pain. Okay, so B is A is. I'm going to type that again just so I can screenshot it. Again, please skip forward, or just listen to me babble. 0, 0, 120 times 9.81. What? Oh my, wait. Three rows, 1 column, by 3. What am I? Why am I literally not? It's MATLAB that is giving me the trouble at the moment. My trusty calculator has failed me. I have a 3x3 divided by a 3x1. I'm just going to use the linsolve, I guess. Why, MATLAB, why? Okay. Here we go, finally. I will do 2 screenshots, because I don't Alright, so this is my A and my B. My B should be the name of this video because my B. But I promise no edits, and so no edits you shall have. There it is. And just this time I said at the beginning I learned some lessons. And I did. So this is the solutions document. Oh, it's not quite the solutions document. I must have messed. It's pretty close. I must have made a math error in here somewhere, or maybe the solutions made a math error somewhere. But it's more or less right. The solution said 5, 6, 9, 3, 7, 6, 4, 6, 7. So somewhere in here I made an oopsie. But I will leave it as an exercise to the reader to find my mistake. Yeah, so this is how you would generally solve the problem, though. Big takeaway, write your system of equations, and then say, hey, look, it's a system of equations. I'm solving this with my calculator. And then plug it into your calculator and get your unknowns. Sound good? Okay. One more coming up.